What I would like to do is describe your next project for you. I thought it might be helpful to do this in addition to the project description that I provided. So what you're going to do is accumulate all of your knowledge and all of the things that we studied this semester into a single diagram, okay? How you do this is up to you. So the diagram, I gave you 3 different samples. Those are very, very basic diagrams. You can use those as a guide and do something similar, or you can do something completely different. You can go out of the box if you want to. I encourage you, if you're not sure if your diagram is going to work, you can send it to me through email, or you can even post it in Blackboard, and I can give you some idea as to whether or not I think it's a diagram that you're going to run into trouble with as you keep adding things to it, okay? So what do we mean by mathematical connections? Every single function that we've studied is related to another function in one way or another. Sometimes it's related to multiple functions. What I would like you to do is show these relationships, okay? So we discussed all different kinds of functions. I put those in the project description, so I'm not going to write them again here, but I will say them. We've talked about linear functions, polynomial functions, rational functions, reciprocal functions, which you are studying this week and next week. Trigonometric functions, which we have not covered yet. That's the last couple of weeks of the semester. Exponential functions, logarithmic functions. We've talked about radicals. We've talked about absolute values. So we have a lot of different things that we've covered. And what you'll notice is that there are some sort of patterns between them. Some things that apply to some functions, but not others. And eventually, you'll see that there are some things that apply to every single function. So for example, what's something that we notice a commonality between 2 different functions? Well, linear functions and polynomial functions both have end behavior, okay? The end behavior for a linear function is a little bit easier to predict because it's just about slope. But for a polynomial function, we use the leading coefficient and the degree to help us. We do that in the linear functions too, but we need it much more in the polynomial functions. So how can we show that this is a commonality? Well, one way that you can do it is you can do it almost like a spider web, where you have the type of function. So here's our linear functions. Here's our polynomial functions. And then you can just create almost like a web that connects it. So here's our web. And we're saying we can predict end behavior. Okay. We can take something like exponential functions. We can add to this. So maybe you put that down here. And for all of these, the domain is all real numbers. So we can draw a connection between these. Okay, so it's almost like you're drawing some sort of spider web. Okay, you can include, let's say that we put logarithmic functions in here as well. Well, it turns out that logarithmic functions and exponential functions and linear functions, these are all 1-to-1. So you could keep doing this with all of the different types of functions that you have. You can talk about the ones that have inverses. You could talk about, we're going to be discussing transformations soon. So you would add that to your diagram. You could talk about different equations. In some of the diagrams that I gave you, I talked about the fact that something like a logarithmic equation requires us to check for extraneous solutions. We have other types of equations where we had to check for extraneous solutions. So you can do some sort of spider web type thing in here, okay? This isn't the only way that you can do it. Instead of keeping your functions separate, you can keep these types of things separate. So you can have almost bubbles for each one of these. So if we wanted to do something similar, we can say, so this would be like another type of diagram that we do. We can say, okay, let's put in this box everything where we can predict end behavior. And right now we can do this with, we said, linear functions and polynomial functions. Then you can have another circle that represents 1-to-1 functions. So this would be exponential, linear, logarithmic, and you may add to this at some point. Okay, and you may decide to put, okay, linear, but let's leave out, we're going to put except horizontal lines. Okay, so you may stick one of those in there. Then you can talk about things that have the same domain. And you can say, okay, linear functions have a domain of all real numbers. Exponential functions, we know. I put logarithmic, but I'm actually wrong about that, right? Oh, never mind. Sorry, I got confused. Linear, exponential, and polynomial. Okay. You could do the same thing even when you do these functions. When you do it like this, you might decide, okay, I'm going to do it this way, but I want to specify the difference between functions with odd degree and functions with even degree, because there might be some things that we know we can do when we have functions with odd degrees and functions with even degrees. So you might have like a bigger box around here, and then it might be true that you know that the functions with odd degree have some characteristics that you can share with other types of functions that functions with even degree do not. Okay, so it might be domain, it might be range. Okay, odd degree functions with odd degree are going to have a range of -infinity to infinity, whereas functions with even degree do not. Okay, so if you talk about range, you might just connect the linear functions with the functions with odd degree. Okay, whereas if you're talking about range, functions with even degree might just be connected with exponential functions. So those are things that you would do. And it might be that you're seeing a connection, but then you have additional text. Maybe you put a star next to this. Instead of the except horizontal lines, you put a star instead. And then at the bottom of your page, you put except horizontal lines so that it doesn't get in the way of your diagram. Okay, so whatever is going to make your diagram as clear as possible, that's how you're going to do it. So you can have additional text in there. That's fine. So when I talk about the additional text in the rubric, I mean this. I mean this predicting the end behavior, one-to-one, anything that you have in here at the bottom or off to the side that might clarify what's in the diagram. But what you're doing is you're showing how these different functions are related. Now, these are not the only ways to draw the diagram. I think I have an extra sample in there that you can use or create your own, okay? This is the way in my mind I might organize the data, but it's not necessarily the way that you would organize the data in your mind, okay? If you have any questions, send me an email, come to my office hours. And if you just want to show me a rough draft just to see if you're getting everything, then you can show that to me as well. I do recommend that you start this now, but plan in your diagram to include trigonometric functions, okay? And you'll see that trigonometric functions, just like polynomial functions, can be divided, right? Maybe you're just dividing it into quadratics, and then functions with degree greater than 2. Okay, that might be the way that you divide it. That's up to you. It's whatever patterns that you see. Trigonometric, there are lots of different kinds of trigonometric functions, so you may group those into different categories like you do here with the polynomials, or you might just decide to group trigonometric functions all together, and then if something applies to just some trigonometric functions, like here we have one-to-one applies to some linear functions, then you can just put stars at the bottom or something at the bottom, footnotes, however you want to do it, okay? You can present this in a few ways. You can do it with a Prezi, okay? Anybody who's used Prezi before, that's like a presentation program. You can do it with Microsoft PowerPoint. You can just attach a diagram, but you must have a diagram. You cannot just do this with text, okay? You can't just have paragraph or list that says all of the different relationships. We need a diagram in there, okay? And again, if you have questions, just contact me.